Hello, today we're going to be solving a physics problem for motion in 2 dimensions. So the problem is a car drives off a cliff with a horizontal speed of, or velocity of 20.7 meters per second. The car is in the air for 5.3 seconds. How high up is the cliff from the ground? So right now we can we're going to be using these equations and deriving certain components from it to calculate the certain components. So we know that displacement is initial velocity times time plus 1/2 acceleration times squared. And we also know that acceleration is equal to final velocity minus initial velocity over time. So we already have written down, since we know that the air time is 5.3 seconds, so we can write that for vertically and horizontally. So this curve here represents the path of the car. And hold on, let me just erase this because this is for something else. Um, and we have that the velocity, initial velocity at least, horizontally is 20.7 meters per second. So since there is no outside force affecting the horizontal velocity, um, once it goes 20.7 meters per second, it will be going 20.7 meters per second for the entirety of its course, horizontally at least. So we can conclude that final velocity will also be 20.7 meters per second horizontally, meaning acceleration is zero because there is no acceleration. It's going at a constant velocity. Okay, so another thing we do know is that uh, hold on, let me just adjust the camera a little bit. Um, Vertically, the acceleration is negative 9.8 because that's the acceleration of gravity vertically. So A equals negative 9.8 meters per second squared. And we do know that since it's starting at the top of a cliff and it's not going down until it leaves the cliff, we can say that vertically the initial velocity will be equal to zero. So we know time, we know initial velocity, and we know acceleration. So we can derive the final velocity from that. So we go negative, because we know the acceleration equation right here. So we plug the values we know that we have into it. Negative 9.8 equals um, VF, that's what we're solving for, minus 0 over 5.3. So we could do the dimensional analysis over here. Wait, yeah, negative 9.8 ms squared time, we're multiplying by 5.3 uh, seconds. That second cancels out the square. The square that there cancels out, so it just becomes meters per second, which is what velocity is. So um, so we do negative on our calculator. Sorry for the brightness difficulties. Not much I can do about that, but negative 9.8 times 5.3. Sorry about that. Negative 9.8 times 5.3, which equals negative 51.94. So we write down here negative 51.94 equals final velocity vertically. So we have that, and now we're trying to calculate the displacement vertically. We have um we have initial velocity, and we have time, and we have basically right here we have everything we need to calculate displacement for vertically. This calculation right here may seem unnecessary. Sorry, my camera froze. Just give me a second. All right, there you go. Sorry about that. I'll just try to start back from where I remember. So this calculation right here may seem unnecessary, negative 51.94 meters per second, but on the second part of the equation, it will come in handy. So we can plug what we know into the displacement equation. So displacement equals, uh, we know initial velocity is 0, so 0 times 5.3, which essentially is just 0, plus 1 half negative 9.8, and then 5.3 squared, because that's the time. So that and essentially just becomes 0, so we could just cross that out. Don't really have to worry about that. And now we go into dimensional analysis. 1 half negative 9.8 m s squared times 5.3 squared seconds. So we have that. So let's go into our calculator once again. Do 1 divided by 2, which is 0.5, and we get negative 9.8 times 5.3 squared, which ends up being negative 275.282, and you multiply that by whatever you got for 1 divided by 2, which is 0.5. So that's that. And you end up getting your final displacement as negative 137.641. Now, you may be a little bit confused since it is a negative number. That is perfectly okay because technically the displacement is negative because it is going down from its initial starting point, which is right here, and its displacement is basically how far it goes down, which is right here, and it's a negative distance because it's going down. But that doesn't mean the cliff is a negative height. The cliff is, you could just remove the negative and conclude that the cliff is 137.641 meters. So the answer to the first part of the question is 137.641 meters. So now for the second part of the question, which is what is the impact speed of the car right as it hits the ground? So essentially what it's asking is like right here, the total velocity, what is its final velocity? So what we do know is that horizontally, as we said earlier, acceleration is equal to 0, and it'll be maintaining a constant velocity of 20.7 meters per second. So we know the velocity there. And earlier, like I said, this will come in handy. We calculated the negative 51.94 meters per second. And again, that may seem confusing because it's negative, but that is perfectly okay because it is going in a downward direction vertically. It's going from here to here. Therefore, it's going to be going down on like, if you draw it out on like a little graph here, it's going down on the y value. And so it's decreasing in y value and going below the origin, hence y is negative. Okay, hold on. Okay, so we have the two final velocities for vertically and horizontally. And since this does form a right triangle in a sense, we can use Pythagorean theorem to calculate the total final velocity. So we plug in negative 51.94 meters per second, put it into our dimensional analysis setup here, square that, and then actually, you don't even have to do dimensional analysis since we're just adding really. Um, so negative 51.94 m slash s. So make sure to square the actual number, not the units. So add that to 20.7 meters per second, or put the square at 20.7, and whatever that equals, let's put that into our calculator. Negative 51.94, oh, whoops, negative 51.94 squared. Actually, my bad. You're supposed to do a parenthesis and a negative 51.94 squared. Hold on. I'm doing this all messed up. Um, oh yeah, this is how you do it. 51 point. Then put the square on the outside. Okay, so we get 2697.7636, and then we add that to 20.7 squared, and our final answer ends up being 3,126.2536. So we have that 3,000. That is 3,126 0.2536, and that is in meters per second. So since Pythagorean theorem we know is a squared plus b squared equals c squared being the hypotenuse. And we're calculating I guess you could say the hypotenuse here for the final velocity. And so once we have that, all you simply have to do is square root that total, and the square root of that ends up being 55.913 for rounding to the thousands. So 55.913 meters per second. And that is the final velocity, or in terms of the question, the impact speed of the car right as it hits the ground. And yeah, that's how you solve both parts of the problem. Thanks for watching.